So I talked previously about designing, well, why bigger computer chips are a lot better. And also designing kind of a computer with a bigger computer chip with cooling and stuff problems. A specific use that I thought that was actually would really benefit from it is they were talking about for machine learning, for fluid flow simulations. But one of the most complex fluid flows and machine learning thing and data thing to ever exist is weather forecasts. And if we can make weather forecasts a little bit better, it could revolutionize agriculture, safety, road predictions, and so much more. Transportation could become a lot more efficient and a lot safer. People could design better houses, better cooling and with events, and so much more. Events could be better planned. Everything could be done better. And these are bigger chips with chips have been shown to be 200 times faster than some of these models. And the faster something is, the better the model can do. Because one of the simplest ways of improving a model with these models is that they take small time steps. So how these models work, oversimplified, is that they look a certain amount of time ahead in the future. So let's say an hour is split into 10-second chunks, and you try to predict what happens in 10 seconds by updating everything by +1 or plus something else. You update them by a little bit. And it's like making more a bunch of snapshots. Now, the more snapshots you can have, so if you make it every second, the prediction becomes more and more accurate because everything is closer to each other and less weird stuff can have funky in the middle. To kind of give you an example is, if you see me, if you try to predict what happens in the middle between, if you only saw the last frame of a movie or the first frame of the movie, it's kind of hard to figure out what happened in the middle. If you have many little snapshots, it's a lot easier. But it's also a lot easier to see complex motions and stuff like that. So the more snapshots you can have, a lot more accurate. Another thing you can do is you can take a snapshot 10 seconds in the future, and this has been done a lot, and kind of rewind it, see where it needs to focus more, where there was mistakes, and rewind 5 seconds back, and use that time to triangulate and collect stuff. That's a much more complicated method, but it's also pretty widely used, I want to say. And beyond all this methodology that I've been saying right here, is that when you have faster ones, when you have all the speed gain, you can start experimenting with more methods that are more unique or specialized for this, because opens up new territories they couldn't do before. If you can run 100 simulations compared to 20, you can collect more data and use that to find better averages or do fancy statistics that just weren't possible. To give you an idea, if you have 2 data points, the middle between the 2 data points is the same as the average. We take the 2 numbers and divide by 2. If you have 3 data points, it's different. If you have different measurements of variance or something like that, 4 data points is much more different than 5 data points. And so on. And what we do with all this weather forecasting, and this is why it's so different to Texas, is we wanted the weather forecasting with slightly different parameters. And these slightly different parameters build a statistical model, and then we take fancy averages, and not really averages, but sometimes averages, sometimes a much fancier variance, and we build possible trajectories, and we try to use that to update the model, make a better model by all these little models, and we put in a bunch of random variables to see how stable a model is compared to like distribution, so how likelihoods, but also to figure out if we increase the wind speed, will it really affect the rainfall at all, and stuff like that, and to get a better sense and counteract the system and see how delicate the system. But this could lead to a lot more possibilities of how to do that, because you can just run the same simulation over and over again. I don't know how much better, but it could. Then you could also use fancy statistics to improve radar and other measurements of the actual weather in the first place, including better space satellites and stuff to measure weather phenomena, because these better space satellites to measure weather phenomena, sometimes they're actually doing some satellites can get too much data for them to beam down, and having a computer that could like one of these fancy computers, could either compress it better, or it could analyze the data and figure out what chunks to throw away more so you get more useful data. Another way you could do it is you could start more experimenting in labs with weather models to actually develop in labs better weather models beyond just boosting capable models that we already have that I've been discussing. With all this, it's just ideas I have to improve weather forecasting. If you have any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Also, please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. And again, thank you very much. Goodbye.